Okay guys, so what we're going to have a quick look at here is the chemical reactivity of the halogens, which are the group 7 elements. So we've already looked at and explained the reactivity of the group 1, so we're going to look at group 7. So we'll just take a subset of the group 7. Okay, we're just going to look at the reactivity of fluorine versus chlorine versus bromine. And we've already done our practical in class, or we're going to do it very soon, and that should have shown that through the displacement reactions is that the opposite trend is true here as was true for the group 1 metals. So as we go up the group, okay, reactivity increases, or in other words, as we go down the group, reactivity decreases. So our question really is again, well, why is this the case? Why does reactivity decrease as we go down this group? Well, if you think about when we looked at the group 1 metals, when the metal reacted, the metal lost an electron and became positive one. Well, quite the opposite happens with the group 7. Okay, so if we just represent the non-metal group 7 as N, and remember these are all diatomic, so it would be N2. N2, what happens there is that this time it gains the electron, and those of you who are switched on will realise when a metal reacts with the non-metal, it's the electron from the metal that the non-metal gains, and it turns into fluoride ions or chloride ions or whatever ions. But in group 7 they are indeed, as you should know, -1. Now we need to just balance that up, and we can balance it up by just putting half in front of the diatomic fluorine, chlorine or iodine. Okay, this N represents a non-metal, by the way. It doesn't represent nitrogen in this particular instance, so just be aware of that, please. Okay, or we could write that as N2 plus 2 electron goes to 2 N minus, so 2 chlorides or fluorides or bromine. But the key thing is that in this time we have got the non-metal, okay, is gaining the electrons, whereas up here the metal was losing those electrons. Okay, and yet indeed it's the metals from up there that are accepted by the non-metal. Okay, now, so the next thing we say is, okay, well, fluorine is the most reactive of all of these, so it must be the best at gaining these electrons. So if we took fluorine, okay, and we just compare fluorine with chlorine, if there was a fight over an electron, okay, and these things, remember, they react by gaining an electron. If there's a fight over the electron, well, because fluorine we've established is the more reactive, the fluorine will win the fight. Okay, in other words, fluorine can attract electrons more strongly than chlorine can. Okay. Likewise, if we took bromine down here and there was a battle between it and chlorine for an electron, it would be the chlorine that won the battle, and the bromine would not be able to attract that electron. So our next question is, well, why is that? Why is that the case? And it comes down to electron arrangement and shells, as we looked at with our metals earlier. So we have electron arrangement of 2 and 7, electron arrangement of 7, atomic number of 9, atomic number obviously of 17. So let's have a look at a fluorine atom. Okay? So we have 9 protons in the nucleus, and then we have 2, we just write the 2 there, and we have 7. Okay, and with chlorine, okay, we have 17 protons in the nucleus, and this time we have 2, 8, 7. So if we would just simply write 2, 8, 7. Okay, so let's take our electron that these two things are battling over. Okay, and let's have a look and see why would it be that the fluorine wins the battle. Fluorine is more reactive there, and it's gaining electrons. Therefore, the fluorine must, for some reason, have a stronger attraction towards this electron. It must be able to pull it into its outer shell to get this full outer shell of 2, 8, 8. Whereas the chlorine is also trying to get a full outer shell, but it doesn't have as strong as attraction to the electron. Therefore, it simply can't get it when the fluorine's around anyway. Well, what attracts this electron into the atom? Well, hopefully most of you are able to work out what attracts it. It is, of course, the positive nucleus in the middle attracting the negative electron, and that's true for both. Okay, but you might say, well, surely chlorine should be more reactive because it's got 17 in its nucleus, so it's 17 plus putting on the electron would attract it more, and whereas fluorine only has 9 electrons in its nucleus, therefore you would anticipate that fluorine would not be quite so good at attracting the nucleus, or attracting the electrons, sorry. But that is in fact not the way to think about it, and if you think about it in the same way as we thought about the group 1 metals, whenever they were trying to lose their electrons, which was what was the most important factor in controlling the reactivity. Well, it wasn't the nucleus or the number of protons in the nucleus, it was indeed the distance from the nucleus to the outer shell. And if we look at it, remember that chlorine has got 1 extra shell, whereas fluorine only has 2 shells, chlorine has 3. So therefore, it is the distance between the nucleus and the outer shell in fluorine compared to the distance between the nucleus and the outer shell in chlorine. This distance, okay, which we'll call D1, try D2. D2 is much greater than D1. D1 being this distance here. Okay, and if that's D1, okay, and this distance here is indeed smaller than D2, that means that this electron is going to be much closer to that nucleus, and therefore that nucleus has a stronger attraction on the electron than the nucleus of the chlorine, despite the fact that the nucleus of the chlorine is considerably more positive. Okay, so that is the explanation for the relative reactivities of fluorine to chlorine, and the same applies then to bromine. If you were to go further down, yeah, your bromine, if I was to look at my bromine, despite the fact that it has 35 positive in its nucleus, its outer shell, if you want to think of it in that way, is really far away from the nucleus. Therefore, if it's trying to attract an electron, okay, this distance here is so big that the electrostatic attraction that that nucleus would have on the electron that it's trying to attract becomes very, very weak. And if the attraction of the nucleus to the electron is very weak, it can't attract it very much, therefore it's going to be much less reactive than the others. Okay, I hope that clears that up for you. Any questions, come and see me.